Good morning, students. In this video we are going to continue the fourth unit. In that fourth unit we are going to already saw the quantum dots. Quantum dots. Now we are going to see the various manufacturing process of the quantum dots. So in this first of all we are going to see the lithography. So lithography is the one of the technique or one of the process to manufacturing the quantum dots. So quantum bells, here you can see this in this picture they were clearly given. A quantum bell is available in white color. In the above that the polymer marks are covered with polymer marks. After that what they mean, the metal surface will be there. So multiple layers are will be there. They are clearly given. Then after that they are using the electron beam, they were exposed to the electron beam. Okay, here quantum wells are covered with the polymer marks and exposed to the electron or IR beams. Here you can see this, the quantum well is available middle, then covered with the polymer marks. Okay, polymer marks in the electron beams is striking that are exposed to the quantum bells are exposed to the electron beams. Okay, ion beams we can tell. The surface is covered with a thin layer of metal, then cleaned only exposed areas keep the metal layer. Here you can see this. The surface is here. The next thing is a surface. After that process, the surface is covered with the thin layer of metal. Okay, then cleaned and only exposed area keep the metal layers. Exposed areas keep the metal layers. Okay, pillars are each the entire pillars are each the entire surface. Then multiple layers are applied this way to build up the properties and size wanted. So this is the method. Quantum dots is the quantum dots for making a quantum dot process. So after that what they are doing, they are applying the etching process, activation of ions. What they are making that quantums. Okay, quantums. Here we are going to see the photolithographic technique, the continuation of the lithographic only. So what is photolithography? Photolithography is the process of transferring geometric shapes on a mask to the surface of silicon wafer. Here they can see this. Okay, first of all this is the silicon. Okay, then yellow color indicating the silicon dioxide, then blue color indicating the photoresist. Then here photolithography steps are they were given. First wafer cleaning process. Here in the first step the vapor are chemically cleaned to remove organic, ionic and metallic impurities. In this first step, okay, we are removing the organic, ionic and metallic impurities. Then in the second process, barrier layer formation. After cleaning silicon dioxide, which serves as a barrier layer. Okay, we are cleaning a initial silicon. Okay, after that what we are doing is silicon dioxide, putting the silicon dioxide, it will be served as a barrier layer. It is deposited on the surface of the wafer. Then third one is the photoresist application. Here you can see this, the photoresist is applied. Here you can see this, that blue color is applied on to the surface of the wafer by high speed centrifugal spinning. Here you can see this, the spin coating method is provided. High speed centrifugal spinning process. This technique is known as the spin coating technique. Produce a uniform layer of photoresist. Okay, photoresist on the wafer surface. In this process, a liquid solution. Okay, a liquid solution of the photoresist is give out from the wafer by the rapid spin and produce the uniform layer. That means 0.5 micrometer to 2.5 micrometer they will producing. Okay, spin coating or spinner typically runs at 1200 rpm to 4800 rpm for 30 to 60 seconds. So chemicals are, what are the chemicals we are using in the photoresist are, one is polymethyl methacrylate, okay, methacrylate, then polymethyl glutamate, then polyformaldehyde resin, phenol formaldehyde resin. This is the easy, okay, these are the chemicals we are using for making that photoresist application. Then the fourth one is in this positive photoresist. What is positive photoresist? Here you can see this, okay, the silicon dioxide, in the above silicon dioxide only the blue color will be there. So what is the meaning? The positive photoresist is you exposed to ultraviolet sunlight, okay, ultraviolet, not sunlight, ultraviolet light, the underlying materials to be removed in this resist. Exposure to the ultralight changes the chemical structure of the resist, okay, chemical structure of the resist, so that becomes more soluble in the developer, the exposed resist is then washed away from the developer solution. So here there is this in this picture, the yellow color, above yellow color, some of the solution will be there, that is washed with the help of the developer. In other words, whatever shows goes. So here the only available, this is the required thing that will be available. Then in negative photoresist have just in opposite manner. Here you can see this, here the only this is the required thing, so the remaining thing will be removed. Exposure to the ultraviolet light cause the negative resist to become the polymerized. The negative resist, this is the negative resist, this is will be the polymerized, so and more difficult to dissolve. Therefore the negative resist remains on the surface. So this is the negative resist, there remains on the surface after the exposure to the developer solution. So removes only the unexposed portion. So this is the unexposed portion that will be removed with the help of the developer. Fourth point is pre-baking. Okay, here you can see this. You can based on this picture you can easily understand. Pre-baking is the step during which almost all of the solvents are removed from the photoresist. So with the help of the 90 degrees to 100 degrees Celsius pre-baking process, we are removing the unwanted solvents. Okay, we are removing the unwanted solvents. Now next one is mask alignment and exposure. So a mask or photo mask is a square glass. Here you can see this two square glass are with a patterned combination of the metal film on the one side pattern transferred to the onto the wafer surface. There are three primary exposure methods: contact, proximity and projection. One is contact, proximity and this one as shown in figure. Based on here you can see this, we are applying that, okay, with the square pattern type, square glass type we are kept above the mask, okay, above that pattern we are keeping that pattern. After that we are applying that some of the ultraviolet or ultralight or whichever the pattern is required, we are making that, okay. So in this process three methods are there for making this process. One is contact, next one is proximity and third one is projection. Here in the contact printing, here you can see this contact printing. This is the contact printing. Here light, okay, shows is applying to the optical stream. After that a mask will be kept about nearly attached to the photoresist. In contact printing, wafer is brought, okay, contact printing wafer is brought to into the physical contact with the photomask. So here the wafer is directly physical contact to the photomask. Because of the contact between the resist and mask, due to this what will be, we are getting the very high resolution. The problem is with this the fragments is, some of the particles are trapped between the resist and the mask, can damage the mask and cause defects in the pattern. Proximity printing. The proximity exposure method is similar to contact printing. Okay, here you can see this is similar to the contact printing, but some gap will be there. The gap is between the mask and the photoresist. Though here you can see this 10 to 25 microns is widened, maintained. Widened. Here you can see this 10 to 25 microns is widened. Both sides are, they were kept 10 to 25 microns are widened. This gap minimizes the mask damage. Approximately 2 to 4 micron resolution is possible with the proximity printing. Then last one is projection printing. Here you can see this projection printing. The projection printing avoids mask damages entirely. An image of the pattern on the mask is projected on the wafer. Which is many centimeters away. To achieve resolution, only the small portion of the mask is imaged. It has about 1 micron resolution. Then development. Development is a process which exposed or non-exposed area is dissolved by the developer. So we are using that whichever the part is required or not required part is dissolved by the developer. Most commonly used developer is tetramethyl ammonium hydroxide is used concentration of 0.2 to 0.26. Developer is the important in controlling the development uniformity. Therefore, two methods are used: spin development and spray development. Here you can see this. Here they were used to spray development. Okay. In case the nozzle is rotating form is, they will use the spin development. Okay. During the spin development, wafers are spin. Sorry, this is the spray development. Wafers are spin and developer is poured onto the rotating wafer. Okay. When it is rotated, that will be spin development process. In spray development, the developer is sprayed rather than poured. Okay, poured. Okay, on the wafer by using the nozzle that produces the fine spray over the wafer. Then hard baking. The hard baking is used to harden the final resist image at the temperature 120 degrees to 150 degrees, so that will hold out the harsh environment of etching. Etching is performed using the wet chemicals such as acids, or more commonly in dry etching. The photoresist will resist the etching and protects the material covered by the resist. When the etching is completed, the resist is stripped, leaving the desired pattern. So last one is stripped. After the image wafer has been etched, the remaining photoresist must be removed. So remaining photoresist, this is the final formation. Therefore, there are two classes of stripped techniques: wet stripping and dry stripping. There are two processes are there. A simple example of stripper is acetone. Acetone tends to leave the residues on the wafer. Most commercial organic strippers are phenol. Okay, so the application of photolithographics are main application is IC designing process, internal combustion designing process. Other applications are printed electronic boards, nameplate, and printer plate. So these are the simple applications. Okay. Next year EBM. Okay, up to this we saw the photolithography technique. So in this we saw the one of the method photolithography. The main disadvantage of the lithography techniques are it is a slow process and the contamination is very high. Okay, the contamination is very high, low density, and defect formation. Okay, defect formation. So this is the lithographic technique process, and we also saw the photolithographic also. So with help of this, you can easily understand how the quantum dots are developed. Okay. So in the next class, we will see the another process.